Okay, good morning class. Today we're going to have a lecture on topics that are important for your profession as future nurses. We're going to talk about conditions that affect the heart, right? And then later on we'll talk about heart failure and different forms of shock. Okay, can anybody tell me what is the main function of the heart? What does the heart do? Anyone? It what?
It pumps out the blood.
It pumps blood. Very good. Okay? So we know the heart pumps blood, right? So apparently when the heart pumps blood, it is a muscular pump, right? Remember? Okay, everybody please do this. Make a fist with your hand, okay? And put that fist in front of your chest, okay? Technically, the heart should be found behind the sternum. The sternum is the bone that you find here in front, right? So if you put your hand, your fist behind the sternum, that is the same size as your heart, okay? We know it's a pump, okay? So therefore, when a patient comes to the emergency room and does this, what is he suffering from? She has chest pain, and most likely what organ could be affected there? The heart, right? So that's the reason why the foundation of both medicine and nursing will always be what? Anatomy, right? Study of human body structures, and physiology, which is the study of human body functions, right? So it would be useless to know the structure, but if you do not know the function. We know the heart is a pump, right? So here is a model of the heart. It's not as big as my heart, but this is designed to show you the different structures that are found within the heart, right? So take a look at this. The heart, as you can clearly see, has 4 chambers. Can anybody tell me, or can you tell me what is this chamber here on the right side, on top? It's called the right atrium, right? And then you can see here that the one below is what? The right ventricle, right? Okay. And what is this blue blood vessel on top of the right atrium? It's the superior vena cava. What about the one below? Called the inferior vena cava, right? Okay. And if you will notice, what is the color of the blood vessel and the chamber here? Blue. Why blue? Because it represents what kind of blood? Venous blood. You are precisely correct. Deoxygenated blood, blood rich in carbon dioxide, right? All the veins in the head, the neck, and the upper limbs, as you can clearly see here. See my veins here? See? These are veins, right? Okay. The veins you find here in the head, the neck, upper limbs, like these veins here, all the blood that is drained from there, from the different cells there, are carrying blood rich in carbon dioxide. Where do they go? Into the superior vena cava. What about the veins in the leg, the feet, the thigh, and the lower abdominal and thoracic region? The veins bring the blood where? In the inferior vena cava. So think of this as the 5 North Freeway or the 5 South Freeway here in Los Angeles, California, right? So you have a 5 North, okay, going up, and then a 5 South going down, right? So apparently these are major blood vessels, okay? The reason why they're blue, because they carry deoxygenated blood, which means that this blood contains mostly what? Carbon dioxide transported by the red blood cell, right? So they go to the right atrium, passing to what valve? What valve do you call? What do you call this valve here? Tricuspid valve. See why? Because you want 1, 2, 3 cups. So as you can see here, there are 3 cups. 1, 2, 3. 1, 2, 3. A valve is found between the right atrium and the right ventricle, right? And what is the function of the valve? Can anybody tell me? Prevents what? Prevents backflow, or what we call regurgitation. What else? It allows the blood to flow in one. Remember? I always joke this last time. It's like the band, right? One direction, right? The band called One Direction. Now, from the right ventricle, where does the blood go? It passes through the pulmonary semilunar valve, which is also a tricuspid valve, and then it goes where? Into the pulmonary trunk, and it has 2 branches, the left and the right what? Pulmonary artery. The left pulmonary artery goes where? To the left lung. Where does the right pulmonary artery go? To the right lung. Very good. Okay? And what happens in the lung? What do we do with the carbon dioxide that reaches the lung? We what? Exhale. Why? Because it is something we do not need, right? It is what? Waste, right? And who will benefit with the carbon dioxide that we exhale? The plants. And what do the plants do? Or the trees do? Convert that into what? Oxygen through photosynthesis. Isn't that amazing? We give carbon dioxide to the environment, and the plants convert that into what? Oxygen that we need. So what do we do with the oxygen? Okay, everybody inhale. Exhale. Inhale. Please don't fart. Okay. Oh my God, you're smiling. You must be the one who farted, right? Okay. Now, so when the blood goes back from the lung to the heart, it passes to these 4 major blood vessels. They're called pulmonary veins. 1, 2 on the left, from the left lung, and 1, 2 on the right lung. Why do you think it's now red or reddish brown in color? Because now the blood contains what? Oxygen, right? Transported by still the same bus, the red blood cell bus, right? So the blood now contains oxygenated blood. It goes where? Into the left atrium, passes to, unfortunately the valve is destroyed, it's not here. It's called the mitral valve, or what we call bicuspid valve. And then into the left ventricle, right? And then finally, when the left ventricle pumps the blood, it goes where? Into the aorta, aortic valve, and then goes what? Ascending aorta. Why? Because it is what? Why is it called ascending aorta? It's going up, right? And then it goes into the arch, right? And then why? Because it forms an arch, and then it goes down. It's called descending aorta, right? Okay. And then it goes into the thoracic cavity, becoming the thoracic aorta. And the moment it pierces the diaphragm, it enters the abdominal cavity. It's now called what? Abdominal aorta. Now we divide into 2 what? The left and the right common iliac, which further subdivides into the external and internal iliac arteries, right? Okay. Now, the heart has 4 chambers, has basically 4 valves, right? 1, 2, 3, 4. And then observe too that the wall of the heart, if I put my finger here, what do you call the innermost layer of the heart? Wall. Endocardium. What do you call the thick layer here, where the muscles are found? Myocardium. And then the 3rd layer is called what? Epicardium. Right? Okay, so which one is most responsible for the pumping action of the heart? Obviously, it is the myocardium. Okay? So the myocardial tissue is cardiac muscle tissue. And we're going to talk about the importance of knowing that these are tissues, and tissues are made up of myocardial cells. And cells need oxygen and nutrients too, right? Okay? And because of that, does it need a blood supply to itself? Yes. What is the name of the blood supply to the myocardium? What blood vessel brings blood to this myocardium? What's the name of that artery?
Coronary.
Very good. Okay? What's your name?
Grace.
Miss Grace, yes? How many coronary arteries do we have? They come from the aorta. Remember, the aorta is the major artery that came from the left ventricle. It carries oxygenated blood. You have 2, right? 1 on the right coronary, and what? 1 left coronary, right? Now, the bottom line, therefore, is that being an organ and made up of tissues and cells, it requires oxygenated blood provided by the coronary arteries, right? Do you understand? There's right and left, okay? Now, think of these arteries as tubes, and what do they carry with them? Blood, right? And in this case, what kind of blood? Oxygenated blood. Why are they needed? Because they are expected to bring blood where? To the myocardial cells, which requires oxygen, nutrients also, right? Okay. Now, we're not going to the details of the branches. Technically, you have a lot of branches here, the right and the left. Left anterior descending branch, and the right coronary goes down to the back, which becomes the posterior descending artery here, right? And the left, have the left anterior descending, anterior because it's in front, descending, it's going down, and then left will have a circumflex branch that eventually comes out here at the back, okay? Now, as I have explained to you before, in the study of pathophysiology, we need to know our anatomy. Anatomy is always the foundation of nursing, right? Okay? So, one of the first conditions we're going to talk about is called myocardial ischemia, right? What does ischemia mean, class? Ischemia means what? Anyone? What's another word that means ischemia? Or what do you mean by ischemia? Yes, my dear. What is ischemia?
There's no
There is no blood flow or decreased blood flow?
Decreased blood flow.
Okay, decreased blood flow, okay? So this is the heart. Make the heart big. This is the left ventricle here. This is what? The aorta here. Right? And the first branch from the aorta would be what? The right and the left what? Coronary arteries, right? So, it's like a tube like this. Every time the heart pumps blood, it's basically due to what? The pumping action of the main pump, which happens to be what? Your left ventricle, right? So apparently, back, the blood goes where? To all the organs, even the heart itself. Can you just imagine? The heart is so smart, it pumps blood to itself. Because why? It's made of organs and tissues and cells. It's an organ. And it also requires oxygen. One of the organs would be what? Remember the word subclavian here? Left subclavian artery, which goes to become axillary, then axillary becomes brachial, and then brachial becomes what? Radial and ulnar to supply the upper limbs, right? Then you have the left common carotid, right? Common carotid is found in the neck, goes up here, divides into the external and internal carotid, then it becomes what? The arteries to the brain called cerebral arteries, right? So a CC, common carotid becomes IC and EC. E stands for external, I for internal carotid, and eventually they go to the brain to become what? Cerebral arteries. So what am I trying to show here? Knowing your anatomy will make you understand the things you learn here in this class, right? Particularly with regards to how is it possible for the heart to pump blood to the brain? It's like your 5 north again. 5 north, and then you get the 170 freeway, and you end up with your destination, which is the brain, which happens to be, might be our compass, right? The bottom line is that it tells you that there is a possibility that science can have a problem here, like a blood clot that can travel from the heart to the brain when you have a cardioembolic stroke. Does that make sense to you guys? Right? On the right side, you have your brachiocephalic, which divides into the right subclavian and right common carotid. And the same thing, the subclavian becomes axillary, axillary becomes brachial, brachial becomes what? Radial and ulnar. Okay? Supplying the extremities in the forearm and the hand. Okay? Now, once it pierces the diaphragm, the aorta becomes what? From ascending aorta, arch, and then descending the thoracic aorta, it becomes what? It becomes your abdominal aorta in the abdominal cavity. Once it pierces the diaphragm, external iliac divides into external and internal iliac, which came from the common iliac branch, main branch, right? Okay. So the idea here is that the heart is such an organ, it pumps blood into the other organs by the contraction of the muscles here in the left ventricular wall. Okay? And as you can see, therefore, as we have explained, the right atrium and the right ventricle is here. You have the superior vena cava, and then what's the other blood vessel that brings blood there? Inferior vena cava, right? So, in the case of the kidney class, what's the name of the organ? Artery is called what? Renal artery, right? So every organ will have its blood supply. The brain, kidneys, both right and left. Okay? At the same time, your liver, called hepatic artery. And then for the kidney, renal artery, splenic artery for the spleen. And then each of these organs will have what? A vein. So example, in the case of the kidney, it's called renal vein, right? Okay? So the renal vein brings blood where? To the vena cava. Which one? Inferior or inferior? Inferior. Okay? And this is the one that brings blood where? Here. So as you can see here, what kind of diagram do you see? Do you see a big circle there? See? I did not draw the lung anymore, but it involves the lung. So that's what it's called. Remember the word circulation. Blood circulation. Circulatory system. It's a series of pumps at the same time with the blood vessels bringing blood into the heart and into the lung, going in and going out. The idea, therefore, is that you have to have a very thorough knowledge of anatomy in order for you to be able to understand what is going to happen in our patients. Okay, the first condition. When I told you about this patient who went to the emergency room complaining of, what is that? Chest pain. What is the term used? The scientific term, yes?
Angina.
Angina, very good. And angina is chest pain, right? Why would there be chest pain? Yes, yes, my dear. Why would there be chest pain? What could possibly cause chest pain? Of course, we talked about the possibility of a heart condition. Other conditions could be the lung, right? Associated with problems with breathing or shortness of breath. It could also be the muscles here, pectoralis major, or it could even be the rib cage that's inflamed. But those are not life-threatening conditions. Only two organs that are involved with chest pain, like your heart and lungs, can be what? Life-threatening, and which can kill you. Okay? Why would there be chest pain in patients with angina? Can anybody tell me why? Yes? Don't be afraid to speak. This way, the way you can clarify things. Why would there be angina here in this case?
There is not enough oxygen
Why would there be not enough oxygen?
because it's obstructed.
Okay, what is causing the obstruction? What is found here on the wall of your coronary arteries? A plaque. What's a plaque? P-L-A-Q-U-E. It's a fat deposit, right? It's called atherosclerosis. Okay? Athero what? Sclerosis. What is that? Deposition of fat, and that fat deposit is called a plaque. Okay? A plaque of recognition that you're not careful with the food you eat. Now, I always make this as an example. Look at my tummy here. There's so much fat, right? Why? Because I love to eat. So this excess fat of mine will probably go where? Can they go to my coronary arteries? Yes, they could, right? And when you have fat deposits here, guess what's going to happen? It will, what happens to the radius and diameter of your coronary arteries. So if this is the coronary artery like this, it becomes narrower because there is now an obstruction to the flow of blood, right? Okay, remember what we talked about last time? Q is equal to P over R, where Q is what? Blood flow, and R is your pressure, what? Delta or gradient. And R is what? Resistance. And remember the Poiseuille's law? Where R, or resistance, is equal to 8 L over what? Pi R to the 4th. R representing radius of the blood vessel, like this one here. And then what is L? Length of the blood vessel. And what is L? N. Viscosity of the blood. Now take note, resistance and radius, what is the relationship? Inverse. In other words, the moment you have fat deposits here on the wall of the artery there, what will happen to the radius? It goes down. What happens to resistance, or the opposition to blood flow, would be what? Higher. And if you increase resistance, what happens to the blood flow? Decreases blood flow. And that is what we mean by the word ischemia. So what condition are we having here now? It's called ischemic heart disease, or otherwise known as atherosclerotic heart disease, otherwise known as what? Coronary artery disease, which basically is, the pathology is due to the fat deposit called atherosclerosis. Do you understand? If you have any question, raise your hand, okay? The idea here is that if you look closely here, there are a lot of factors that leads to heart disease. One of them is cholesterol levels. When you have hypercholesterolemia, what does hyper mean? High. Cholesterol-emia means blood. So we normally check for your cholesterol levels. We have the HDL. Which one is good cholesterol? HDL or LDL? Which one is a bad cholesterol? Very good. So the idea, we have to be careful with the food we eat. We have to be careful with your weight. Like as I told people, I used to be 140 pounds. Now I'm almost 200 to 205 pounds. What happened here? Every time I pass by Panda Express and all these restaurants, oh, I salivate. I cannot control my appetite. Guess what? So much fat. Second, do I exercise? No more. As I've told before in my Tuesday class last Tuesday night, I said I used to be playing basketball from grade school, high school. And in fact, I was a varsity player in high school and medical school, right? I would run from end of the court to the other end. Now the only exercise I get is when I walk to my car. Third, sedentary lifestyle is going to cause you more Like me, instead of using what? The stairs, what do I use? The elevator, right? So that's another thing, okay? And of course, if you have a genetic, like my father had hypertension. He suffered from stroke, right? Because he had hypertension and heart disease, okay? Now, so you have chest pain, right? And what kind of chest pain would you experience here? The chest pain is so heavy, it is found behind the sternum. It's retrosternal. Retro means behind. It is so heavy in character that you would experience it like an elephant on top of your chest. And this pain will radiate where? The shoulder, the armpit, the arm, forearm, and the hand, and the jaw. So the typical of chest pain of cardiac origin, which means the chest pain came from the heart condition. Do you understand? Okay? Now, so you have here a condition where there is ischemia. Now, when is it going to be life-threatening? From ischemia, what happens? As time goes by, what happens? The blood flow becomes what? Slower and decreased, and then eventually you end up with what? A blood clot, right? And if there's a blood clot and fat, it combines together to form a complete obstruction to the flow of blood. What happens to the blood flow here? Zero. And when there is zero blood flow, there is no oxygen. Those muscle cells will what? Die. That is what we mean by the word MI. What is MI? Myocardial infarction. Infarction means cells are dead. Why are they dead? Because there is now a complete obstruction of blood in the coronary arteries of the heart, causing the cells to die. There's no more oxygen, there's no more glucose for their nutrients. Do you understand? So you see the big difference? Therefore, it's very important that we in the medical world, the doctors and nurses, come up with ways to determine, is this just ischemic heart disease or is it due to a myocardial infarction? Okay? So one of the things that we normally use is a device called what? EKG. Very good. And what is EKG? What does EKG or ECG stand for, my dear? Yes? What's your name? Javier. What is ECG? Electrocardiogram, which means an electrical activity of the heart is being recorded by a machine or a device. We put electrodes in the chest, on the limbs, and you see a machine that shows you the functions of the heart, right? Okay. Now remember, I always say this, I always try to sing a song so that everybody remembers it. Remember the alphabet song? A, B, C, D, E, F, G, H, I, J, K, L, M, N. What comes after O? P, Q, R, S, T, U, and me. We're gonna study the ECG. Boys and girls, come sing with me and let us learn the ECG. Okay? So, the bottom line is that we use this to determine if there's a problem, right? Now, each of these, if you notice, it says jig, 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 jig. This one is this. The first one is called the P wave, QRS complex, and the third is there a T wave, right? T wave. Now, does anybody remember what does the P wave represent? The P wave represents what we call atrial, remember the atrium? Depolarization by what we remember the word SA node, that's the first pacemaker of the heart, SA node, sinoatrial node. It sends an electrical stimulus or signal to the left and right atrium at the same time to make the muscles what? Contract, contract, so that what? The blood will flow to the left and right ventricles at the same time, right? Then of course, what does the QRS complex mean? Once the blood goes into the ventricles, it has to contract to bring the blood here to the lungs and here to the aorta. So the QRS complex therefore represents what? Ventricular depolarization, which causes the muscles to contract, which causes systole. So first you have to have an electrical event, electrical stimulation from the pacemakers of the heart. Does that make sense? Right? So for example, SA node on the right wall of the atrium, it sends a signal to the left and right atrium. It's called atrial depolarization, represented by what wave? The P wave. Then it leads to what? Atrial systole, making the muscles contract. At the same time, bang, blood goes here, down into the left and right ventricles, and the valves have to open, both tricuspid and mitral valve. And then now, once it gets filled with blood, what happens? The ventricles have to contract, but before it happens, it has to have what? ventricular depolarization provided by the pacemakers. The SA node gives rise to what? The AV node, the bundle of his, right bundle branch and left bundle branch, and the Purkinje fibers, which are responsible for making the muscles in the ventricular wall contract. So go back and review the pacemakers of the heart. Okay? So, the ventricles contract, bringing ventricular systole, brings blood to your other organs, right? Do you understand what? Now, question is, you remember the word regular rhythm? Remember, have you ever heard the heart sounds with the stethoscope, right? The stethoscope? The stethoscope is a device used by us to listen to the heart sounds, right? So when say chig jig, chig jig, chig jig, or lub dub, lub dub, the first heart sound called S1 is due to the closure of the tricuspid and what? Closure of the tricuspid and the bicuspid valve. The moment it closes, you form a sound, lub. Second heart sound, dub or dup, is due to the closure of the pulmonary and then what? Aortic valves. Does it make sense, class? So these valves, when they close, they form sounds. Now, what happens if the valves are destroyed, like you have an infection of these valves, like endocarditis? Because remember, these valves are lined with endocardium. Remember the lining here? And when it gets infected, when you have endocarditis, can this valve be destroyed? They could. So instead of lub dub, we have what we call heart murmur. Have you heard of the word heart murmurs? So instead of lub dub, it would be what? Or chig jig, chig, it would be something like this. Chig jig sh, chig jig sh, chig jig sh, chig jig sh. Or it could be something like this. Chig sh, chig sh, chig sh, chig sh. Is that normal? No, it's not. That means there's something wrong with the valves, right? So we need to examine the valves. We can do an echocardiogram. I don't want to go into the details there, but doctors like me, we like to know what valve is destroyed. We can more or less determine by the kind of sound we hear, based on our clinical experience, right? Now, the other thing you have to remember too is that the electrocardiogram can be very helpful in differentiating angina from what? MI, right? Angina could either, remember the word? Stable, unstable, and Prince-Metal. Which one is relieved by rest? Triggered by exercise. Stable. Unstable, not relieved by rest. What about Prince-Metal? Angina, chest pain. The problem is not because of fat deposit, but rather what? Coronary artery muscle vasospasm, which causes narrowing, causing chest pain. Okay, now, in MI, the muscles are dead. What are the findings here? Okay, first one would be what? Look at the rhythm and findings, right? Now, I forgot to mention, this is called regular what? Sinus rhythm, but the word sinoatrial node. The distance from here to here is this the same, right? Now, have you heard of the word called arrhythmia? What is arrhythmia, class? Without rhythm, okay? When you have an MI or ischemia, can that affect the pacemakers of the heart, like your SA node and AV node? Yes. They're the ones that control rhythm. If you destroy them because of the lack of blood flow, will there be arrhythmia? There will be, right? For example, so instead of you're laughing, right? What happened here was that from an arrhythmia, it became a ventricular fibrillation, and the heart starts to quiver. It's no longer a useful pump, and then you end up with what? A flat line. That means there's no electrical activity. That means if there's no electrical stimulation of the muscles, how can the muscles contract? That's why you have a flat line leads to what? Death, cardiac arrest, right? Do you understand? And what do I say? We get a defibrillator. Either use the AED or automated external defibrillator that we have here in the walls of our building, or in the hospital with the bigger one, right? Stand clear, I'm clear, everybody clear. Right? See? So when you do that, you try to defibrillate the patient if you were successful. Of course, if you were not successful, despite your heroic measures and attempts, stand clear, I'm clear, everybody clear. No response. Stand clear, I'm clear, everybody clear. No response. See what I mean? And we say, oh, time of death, 7:35 a.m. here at West Coast Medical Center, North Hollywood campus, okay? The bottom line, therefore, is that we try to do our best, right? Okay? in order to bring back person to life, right? How many of you have tried doing this? Trying to revive a patient? Has anybody done this? Anybody has done an LVN here? Okay. In the other class I had, somebody said yes. And I asked him, how did you feel? He felt great. Somebody died, and here you are, you were able to revive him. Isn't it amazing? And these are the things we're going to be doing, you're going to be doing as future nurses. Do you understand? You're going to be saving lives. And who knows, I could be one of that patient of yours. So I must make sure that you're the smartest person in the world, right? You know how to use this device. When you try to defibrillate me, you need to know how to operate the machine and device, right? Okay? And why is there a need to defibrillate me? Because I want you to ventricular fibrillation. See? And my heart stopped. Does it make sense? Okay? Do you understand what I'm trying to say here? But aside from doing an electrocardiogram, aside from the history of chest pain, there's another examination that we get the blood specimen. And what is that examination? Can anybody tell me? Anyone? Yes? You have read your book. You're prepared for this quiz today, so I presume you have known a lot, you have a ton of knowledge. Yes? Anyone? Yes?
Biomarker.
Very good. What's a biomarker? Don't be afraid to answer questions, you know. You said to hesitate. Biomarker? No. Very good. Biomarkers. What are biomarkers, my dear?
They include like this
Mhm.
CPB, troponin.
Okay, troponin, your cardiac enzymes like your LDH, CPK, MB, creatine phosphokinase, lactate dehydrogenase. So let me explain it very simply. These are made of muscle cells, right? And these cells, they need what? Blood flow, right? That means the muscle itself has capillaries. Remember the small capillaries are blood vessels that connects the arteries and the veins. A capillary is a blood vessel containing blood. Now, in an MI patient, what happens to the cells? They die. What happens to the cell membrane? They're destroyed. Now, where do you find the troponin, the CPK, MB, and your LDH enzyme or cardiac enzyme? They're inside the cell. LDH, CPK, MB, and of course, your troponin. Remember, in actin, myosin filaments, you learn in anatomy and physiology in muscles. When the cells are dead, membranes are disrupted and destroyed. What happens to the biomarkers or cardiac enzyme? They go where? To the blood. That's the reason why the levels of these will go up. And that tells you that there is what? An MI. People with ischemia or ischemic heart disease, you don't expect the cardiac enzymes to go up. You only expect it to go up when there is what? Myocardial infarction. Do you understand what I'm trying to say? Okay. Now, there are other findings in electrocardiogram that tells you there could be an MI. One of them is called what? Q waves. Now, you remember the word Q? QRS complex here, right? Here. Number one is that we have what we call a significant Q. What is a Q? Q. Okay. 1/3, 2/3, 3/3. That means it's going to be a deep like this. What about a second finding ischemic changes? T wave what? Inversion. And the other one is ST what? What means from S to T straight like this is elevated. ST elevation. But notice in the books that we have used today, it says there's ST elevation MI and non-ST elevation MI. So in other words, even if you do not have ST elevation from the S to T, it could actually be still what? An MI. How? Based on the positive what? Cardiac enzyme levels. So it is therefore the cardiac enzyme or biomarker level that it's going to rise that gives you an idea that you're dealing here with what? A myocardial infarction, which is life-threatening. Do you understand, class? Okay? The idea therefore is that we have to act fast. Anybody with chest pain, are you going to wait for them to die? No. If it's most people have chest pain, let's say 11 p.m. And what would they say to their wife or husbands? Oh, don't worry, honey, I can just go there tomorrow to the hospital early in the morning. And then when you wake up in the morning, your partner who suffered chest pain is now in rigor mortis, dead. In other words, do not take things for granted. You have to go to the emergency room as soon as possible because you can actually have an MI and they have to do something about it. Like, for example, so we have to do all these cardiac enzyme studies, we have to do all this electrocardiogram, we have to put you into the intensive care unit or what we call coronary care unit, and most importantly, we have to give you the proper medication. Now remember, what is the pathology here? there's a blood clot. So what kind of drug will I give immediately? Anticoagulant or thrombolytic drug? What does thrombolytic mean? Dissolve the clot, like streptokinase, urokinase, abokinase, right? But the idea is that it has to be given within the first 2 or 3 hours. Why? Because if it go beyond that, the damage is now going to be what? Permanent. The cells will actually die. Does that make sense? That's the reason why time is of the essence. You have to bring the patient immediately to the hospital. That's why if I plan to retire, I must make sure that my house or apartment complex should be near the nearest hospital, one building away, so that all I need to do is just walk, if not push myself in a wheelchair. I'm just joking, of course. Okay, do you understand, class? Now, second, the idea here is that a lot of them would be complaining of pain, so you have to give something to relieve the chest pain. Do you understand? Okay. Now, what are the things we normally do for these patients? Nowadays, have you heard of the word bypass surgery? Right? Bypass surgery, right? So, what do? We get the leg vein from the leg, of course. Okay, and what do you do with the leg vein? Let's get an example here. Let's say this is the leg vein. This is the leg vein here. Presented by this piece of paper here. This, I cut it from the leg. You ligate, it will not be bleeding. And this leg vein here, remember there is an obstruction here, right? What we do is that we get what? The one end and one end here. You put the other end and you put the other end here like this. Leg vein. You go beyond the obstruction. You bypass the obstruction. So when the blood goes here, it stops because there is an obstruction. What happens is that you give a bypass by allowing it to go beyond the obstruction. You save the life of the patient. If you have triple bypass, it means you have 3 sides, right? There, here, okay? Quadruple means 4, okay? Now there is a different procedure now called Ptca. Does anybody know what Ptca stands for? Have you read it in your book? What we do is we insert a catheter here, remember? Here, in the femoral artery, which becomes external iliac. In common iliac, the catheter goes here. So a catheter is like the small plastic tube with a balloon at the tip. So this catheter with the balloon here is brought here. And then when there is fat deposit in the coronary arteries, and hopefully it's not completely blocked, you inflate the balloon. What will the balloon do? The balloon will flatten the fat deposit. You inflate the balloon, the fat here will be flattened to make the radius become what? Greater, to have greater blood flow. And to keep it in place, to keep it open all the time, you put what we call a stent. So I want you to read on these. Stent, S-T-E-N-T. Now you're a very lucky group of people because why? When I was in medical school, we never had this in 1980s, right? Nowadays we have this, the Ptca procedure. Angioplasty, angio means arterioplasty means repair, which is a form of invasive cardiology. Okay? Interventional cardiology is now being done, amazing. Second, of course, the bypass surgery. Okay? Do you understand, class? Okay? Are there any questions regarding angina, MI? So we're going to stop there first, and then the next topic would be on heart failure. Okay?